Good morning, children. Welcome back. Today we are going to continue with determinants. We are going to learn some extra characters or characteristics of determinants. We are going to learn minor of an element Aij of a determinant. We are going to learn what do you mean by cofactors, and the third one is what do you mean by cofactor matrix. So I have written the definition. Minor of an element Aij is the determinant obtained by deleting the ith row and jth column in which Aij lies, and it is denoted by capital Mij. What does that mean, children? If I have a matrix, say these are the elements of the matrix. Okay. Now if I am writing a 9 and 8. Suppose, children, if this is my matrix and its determinant, I'll write it like this. So it says that if you want to find minor of any element, for example, if I want to find minor of element 1, what I'm going to do is I'm going to delete the row and delete the column in which 1 is there, and whatever value of the determinant. So when I delete that row and that column, I will get a 2 cross 2 matrix, and you know to find the value of the determinant of 2 cross 2 matrix. So that answer will be minor of M11, that means your element 1. Similarly, if I want to find minor of, this is which row? Second row, first column, that means M21, that means minor of 4. Then what I will do? Delete the row, delete the column in which 4 is there. The remaining determinant will give you the minor of that element. Okay, now related to that is your cofactor. Now minor of that element will also have something called as cofactor, and it is given by the formula minus 1 raised to I plus j Mij. So suppose if I want A11, so this will be minus 1 raised to 1 plus 1 M11. So to that value, if you put positions, sign of a negative or positive will give you cofactor. And from cofactor, if I have a matrix of cofactor, how it will be? After calculating all the cofactors of all the elements, you put it in a matrix. That is called as your cofactor matrix. Okay, so A11, A12, you have A13, A21, A22, A23, A31, A32, A33. So these are all connected. Minor is connected to cofactor. Cofactors, after you find all cofactors, if you put it in a matrix, what you get is called as cofactor matrix. Now one important result. What does it say? The value of the determinant of a square matrix of order n greater than or equal to 2 is defined as the sum of the products of elements of any row or column with their corresponding cofactors. Okay, so what is it saying, children? Indirectly, this is what we used to do in determinants, children. If you remember, when we used to solve problems, I used to solve along convenient rows and columns. I used to expand my determinants along convenient rows and columns. That is what it is said here. It says that the value of the determinant of a square matrix of order n greater than or equal to 2 is defined as product of the elements. So you write the elements of that particular row or column. Okay, and then multiply that element with its cofactor and add all that with the remaining elements of that row or column. Then what you get is nothing but delta. This is what we used to do, no, children? This is what we used to do. Now let us apply this to one problem. Let us do this through a problem. Write minors and cofactors of elements of determinant this. So for each element you are going to find minors and cofactors. So let us start with we have to find that it's a 3 cross 3 matrix. We have to find M11, M12, M13, M21, M22, M23, M31, M32, M33. Similarly, for M11 we will have cofactor A11, A12, A3 all. Let us do one by one. So M11 means what, children? M11 means delete where 1 is there. So it will be 5 minus 1, 1, 2. So it is 10 plus 1, 11. So what will be A11? A11 will be minus 1 raised to 1 plus 1 of M11. So that means nothing but this is 1, no? 1 into this is 1 into 11. So it is 11. Okay, now here it is M12, first row, second column. So what is remaining? 3 minus 1, 0, 2. So it is 6 minus 0, which is 6, So A12, that means your corresponding cofactor will be minus 1 raised to 1 plus 2, this position, and M12. This is odd position, so minus, and this 6, so minus 6. M13 means delete that first row, third column. So what remains? 3, 0, 5, 1. So it is 3 minus 0, 3. So what will be my A13? See children, the letters which I am writing is very important. Small aij's, okay, small aij's denote elements, capital aij's denote cofactors, capital M, right, they denote the minor, okay, minors. So this will be into M13. This position is again positive and M13 is 3. Same way let us go for second row, second column also. Second row, first column. Second row, first column. So it will be 0, 1, second row, first column. Second row, first, 0, 1, 4, 2. So it is 0 minus 4, minus 4. So A21 will be minus 1 raised to position is 2 plus 1 of M21. So that is minus of minus 4. So answer will be plus 4. Now M22, second row, second column. Second row, second column. So 1, 0, 4, 2. 1, 0, 4, 2. So it is 2 minus 0, 2. So now A22 will be, position is 2 plus 2 with M22. So it is already positive. So answer will be again 2. Okay. Now 2, 3. Second row, third column. 1, 0, 0, 1. So 1 minus 0 is 1. So A23, because its position is negative. Very easy children, and you can easily score your marks. It is minus 1. That because this is minus and into 1. M31, third row, first column. So 0, 5, 4 minus 1. 0, 5, 4 minus 1. So it is 0 minus 20. Now A31 is nothing but position. So it is 3 plus 1 into M31. So it will be how much? This minus 20 again, because this position is positive. Similarly 3-1 and 3-2. 3-1. What is 3-1? Third row, second column. So 1, 3, 4 minus 1. 1, 3, 4 minus 1. So minus 1, minus 12, minus 30. Position is again odd. So it will be opposite of this. So it will be minus of minus 13. So answer will be 30. The third row, third column. 1, 5, 0, 3. So it is 5. Because it's 0, no? So A33 will be minus 1 raised to 3 plus 3, M33. So it is again 5. So these are the minors, these are the cofactors. Now if you want to find cofactor matrix, what do you have to do? You just write the elements A11, A12, matrix it is, okay. A11, A12, A13, A21, A22, A23, 31, 32 and 33. Understood? Very easy. So these are all minors, cofactors and cofactor matrix. Remaining we'll solve next time.